Buckle up. We're going on a trip. One way, destination, the final moment of the universe's existence. The drive is going to take longer than you can possibly imagine. Along the way, everything you've ever loved, everything you've ever seen will be destroyed, and fair warning, by the end there won't even be anyone left to turn off the lights. But the views are spectacular. Let's go. First stop, right here. Today, it's been 13,800 million years since the Big Bang. The sky above you is packed with stars. New suns are being born, old ones are exploding, galaxies are blazing in every direction. And here's the first thing to understand about this trip. Right now is the best time. This is the peak. The universe will never again be this alive, this bright, this overflowing with light. You and I showed up at the party while it's still in full swing. Enjoy it. It only gets worse from here. Let's keep driving. Foot on the gas. The first 100 billion years. On screen, that number looks harmless, but it's already 7 times the entire current age of the universe. Remember dark energy from last time? That force pushing the cosmos apart, faster and faster? This is where it really gets to work. One by one, the neighboring galaxies accelerate away and slip past the horizon, to a place where their light will never reach us again. The sky empties out. If an astronomer were born in this era, they'd look up and see only their own galaxy, alone in total blackness. They'd assume everything else was a myth. Picture that. An entire civilization that has no way to ever know other galaxies once existed. To them, the universe is a single lonely island of light in an empty void. And we're not even warmed up yet. Next stop, 100 trillion years. This is the era where the stars die. Stars shine by burning fuel, and fuel eventually runs out. The big, bright stars burn themselves out fast. The smallest, dimmest, most efficient ones, the red dwarfs, smolder for a very, very long time. Trillions of years. But a very long time is not forever. Somewhere around the 100 trillion year mark, the last red dwarf in the universe flickers out. In this moment, remember this one. This is the last time a star ever shines anywhere in the universe. The lights go out, permanently. After this, the cosmos sinks into a darkness it will never come back from. Pause for a second and let that land. Everything we call the normal universe, stars, days, nights, warmth, all of it fit into the first tiny chapter of our trip. And we've only just started. Keep going. And here's where the time scale starts to break your brain. We're entering the Degenerate Era. It runs from about 100 trillion years, all the way to 10 to the 40th power years. 10 to the 40th. A 1 with 40 zeros after it. What happens here? The universe has become a graveyard. Cold stellar corpses drift everywhere. Dim white dwarfs, dense neutron stars, dead planets. No light, no heat, just darkness, with the remains slowly cooling. Now a question, what do you think falls apart first? The dead stars themselves, or the very matter they're made of? Pause. Think about it. The answer will probably surprise you. It may be matter itself. There are theories that the proton, the particle that makes up everything, you, this planet, these dead stars, isn't eternal. And somewhere around 10 to the 40th years, protons begin to quietly decay. If that's true, then by the end of this era, even the corpses come apart. White dwarfs and neutron stars simply evaporate from the inside. Ordinary matter exits the stage, and only one kind of object is left. The toughest, the strangest. Welcome to the black hole era. From 10 to the 40th to 10 to the 100th power years. Now black holes are literally all there is. They outlasted the stars, outlasted the decay of matter, and they're left as the masters of an empty, dark, freezing universe. You'd think, there they are, the true champions of eternity. But no, because even black holes die. Stephen Hawking showed that black holes very, very slowly evaporate, leaking their mass back into the cosmos in tiny trickles of radiation. The bigger the hole, the longer it lives. Stellar mass black holes dissolve by around 10 to the 67th year. And the giants billions of times the mass of the sun. Hang on until the very end of this era, until 10 to the 100th year. Stop on that number, 10 to the 100th. It has a name, a googol, a 1 with 100 zeros. To feel that span, take the entire current age of the universe, all 13.8 billion years. Compared to a googol years, that's not a small fraction. It's mathematically zero. It rounds down to nothing. And then the last, largest black hole in the universe releases one final flash of radiation and winks out. That's it. There are no objects left. We've arrived. The final stop. After 10 to the 100th year comes the thing we drove all this way to see. The Dark Era. The heat death of the universe. Picture a cosmos with absolutely nothing left in it. No stars, no planets, no black holes, not even whole atoms. Just the rarest, loneliest particles, drifting ever farther apart in endless, total darkness, at a temperature a hair above absolute zero. Nothing happens. And here's the truly chilling part. Nothing can happen. There's no energy left to move anything. No differences left for anything to change. Scientists call this maximum entropy, a state of perfect, complete, eternal rest. You could say that in this moment, even time itself ends. Because we measure time by events, and there will never be another event again. That's how everything ends. Not with a bang, not with fire, but with endless, smooth, cold silence. The good news, you won't be there to see it. The bad news, no one will. But don't get out of the car just yet. There's one more thing, because the end might not be a full stop. Here's something to chew on. Which ending do you think is scarier? This eternal freeze we've just described? Or the big rip, where dark energy tears space itself to shreds? Tell me in the comments which way for the universe to end frightens you more. And now, the loophole. Some physicists notice something strange. A perfectly empty universe at maximum entropy looks, mathematically, almost identical to the universe an instant before the Big Bang. And if, in that absolute emptiness, a quantum field ever happens to twitch, a new Big Bang could ignite. A new beginning, an entire new universe. There are bolder ideas too, cyclic models, where our cosmos is just one in an endless chain of births and deaths. Maybe the heat death isn't the end of the story. Maybe it's just a very, very long pause before the next let's go. And if so, then you and I got incredibly lucky. We caught the very beginning, the opening moments, while it's still light out, the best seats in the house. If you enjoyed this trip, there's a stop on the channel right before this one. Dark energy, the force that sets the whole ending in motion, already dragging the galaxies into the dark right now. Watch that one next. And subscribe. There are a lot more places ahead that no living thing has ever set foot.